next up, we have Karthic Rao, CTO and founder of Credaro. Also, he's been among the early contributors to Caddy Server written in Go. He's also among the early developers of Minio, an open source alternative for Amazon S3. During his leisure time, he loves to play piano, and he's been a pianist for the last 18 years. And the topic he would be talking to us on is building high-performance deep learning pipeline using Minio, Tensorflow, and Kubeflow. Thank you. Applause.
Okay. Good morning, everyone. I guess this is definitely not how you would want to imagine your Sunday morning, listening to DevOps. But I guess we're almost full. This just proves the fact that Bangalore is probably the tech capital of India. Thanks for being here. So before we begin, how many of you anticipating that your company would have a production-grade machine learning application in a couple of years on the line? OK. So how many of you are machine learning enthusiasts? You want to get your hands dirty doing machine learning? I see. So this talk sheds light upon the challenges of doing machine learning in production. Okay? And first, it helps you understand what are the ground realities and what is that you need to anticipate and to be prepared for when you actually take your machine learning application or your machine learning model to production and build applications which millions of users might later use. And we later use Kubeflow to see how all these pieces can be solved. All these challenges can be fixed in an easy way using Kubeflow. And we'll also see how Minio, which is open source alternative for Amazon S3, plays a crucial role in building this pipeline. Again, to make things simple on a Sunday morning, right, I'll make a simple story. This is the story of Joe and CubeMan. Say hello to Joe. So, who's Joe? Joe is our friendly neighbor who loves machine learning, right? Joe is all psyched up about learning AI, machine learning, and the hype around it, and he just wants to be part of the revolution. And what does he do later? Like most of us do, we start with a simple course on the internet or refer to some materials and start having your first steps in the world of AI. Right. What does he do during his course? What most of us learn during this or whenever we take up some of these courses is that we use TensorFlow, PyTorch and Keras and this popular deep learning framework to build our models, right? And most of these syllabus or this curriculum, they focus upon using smaller data sets and building your model and gives you a wrong assumption that machine learning or deep learning is all about building the right model. Oh yes, Joe is all excited, like how any of us would be excited to start our AI journey, build some models, run it on your machine, see some cool results. Oh yes, life couldn't have been, much happier for Joe because he gets a dream job. He's the coolest dude in the town now. Why? Because he gets to do AI, machine learning. But things are slightly different, compared to what he used to do on his machine and what his course taught him to do, right? And why things were so different? Firstly, is the wrong assumption any newcomer or anyone who lays their hand first time doing machine learning assumes things to be, right? They assume that machine learning and deep learning is mostly to do with just the model, right? get a model right, use your connets, deep neural networks, any of the algorithms, and get the code to run on your machine. And they believe that this probably constitutes the bigger chunk of your entire pipeline. But sadly, unfortunately, this is what the entire pipeline looks like, right? Building a model is just a part of it. And if you look at these different building blocks, each have their own challenges, right? You might start from ingesting the data, which means that you might have customer applications, where you have data coming into web servers, which has to be channelized and ingested and stored, and later analyzed and transformed, and train the model, validate the model, and later, the most important aspect is that once you have a trained model, you want to build an application on top of it. You don't want a useless model, lying around in your storage, and which can't be used to build applications. And later, you want millions of your customers or your customers to be able to use the trained model and build an application on top of it. These are some other challenges which Joe witnessed, right? And in large development teams, it's really hard to get a consistent development environment. We all developers know that, right? But in machine learning or in deep learning, the challenge is much, much bigger because you have compatibility issues with different versions of your deep learning library, and you have like hundreds of Python libraries at times which needs to be used, and the version and the combination has to be right. So the portability issues doesn't just stop at not having a consistent environment across operating systems, but also the issue would be to take your model from your personal computer, which you use during experimentation, to the cloud. But the problems doesn't just stop there. You again have issues with moving across cloud environments, right? So you have different infrastructure providers, you need to get your environment right, and it's really hard to have a usable, consistent environment across all of these systems. Okay, fine. But life becomes really, really tough for Joe now because the problem just doesn't end there. Now, when a company has dozens of machine learning products, or dozens of machine learning APIs, which are built on top of different models, you'll usually have different blocks or these different pieces which has to be put together in a different combination to build your applications, right? You need to, in project number 4, you may want to reuse a piece which you've used in project number 1, and so on, right? But you need an easy way to be able to compose the applications by taking the right recipes, and that's not easy. And when you have so many different building blocks, which together constitutes a machine learning or a deep learning pipeline, you need a really, really easy way to compose the application, to take the right ingredients, put them in an easy manner, and get what you want. Right. The initial days at the company turns out to be a nightmare for Joe. Because Joe is a machine learning engineer, a data scientist, right? He wants to focus on doing data science and not to worry about allocating machines, setting up the storage, ensuring that these machines communicate over a local network, create subnets among them, running the services, service discovery, and the DevOps woes doesn't just stop at some of these aspects. These are just only few worries, which one needs to be anticipating before they take their machine learning model to production. But Joe doesn't want to do that. Joe wants to just focus on deep learning, right? Because deep learning is cool. DevOps is not, is it? I might be saying this in the wrong place. So now, okay. That's cool. Joe thought there was composability problem, there were portability issues, there were DevOps issues, but the biggest challenge is that when you have thousands of customers and data is flowing at really, really, at a scale which you never imagined, Now we have challenges with managing the scale. So which means that you have challenges with respect to ingesting and storing the data. You have challenge with respect to how would you process the gamut of data. And to achieve the computation in a reasonable time, you would also want to distribute the deep learning or machine learning processing. And of course, you have the costing issues, which we'll again focus upon. Right. The performance challenges are really concerning. Like, you might build a really great model, an amazing model, which works great, but if you take a couple of weeks to finish the training and to go out to serve your customers, it's of no use, right? So the challenges are that when you use public cloud storage systems like Amazon S3 or Google Cloud Storage buckets, is that firstly, you need to pull the data over internet, right? You don't have the throughput which you would otherwise get if you pull data over Ethernet. And the next challenge is that the public cloud storage systems will rate limit you. They might think that you're actually DDoSing their systems. I mean, you can't go to them and say, like, I want like 50,000 files at a time because I have a lot of data and I have a lot of clusters to do the training in a distributed manner. But just the fact that now you have to pull the data over internet, and these public cloud storage systems where your data resides doesn't allow you to fetch the data at the rate you want, at the throughput you want it to be, becomes a bottleneck for your performance. Okay. Joe is like enough of DevOps, enough of Azure, enough of Google Cloud, and I don't want to be wasting my time on all of this. Joe figured out that there's a beautiful world called managed services, and where things are really simple, it's easy to get started, and you can just get going in absolutely no time. Joe is back to his happy days. Joe thinks the problems are over. Joe is back to build his models and use these managed services to build applications for his customer. Things were absolutely great until after 30 days. You know what to expect. Right? I mean, this is probably the DevOps guys are always concerned about. We try really hard to communicate to the team or the executive to say that, I know that you would prefer this solution, but just be aware of the billing. Just be prepared for it to have big pockets. And the issue is that managed services are great, but the fact is that in the area of analytics or machine learning or deep learning, you need to also come with big pockets, right? And well, for most of the startups, it makes it hard for them to be profitable, right? It adds more pressure onto the team, onto the business and operational aspects of your company, and it makes it really, really hard and adds immense pressure for the company to be profitable. Imagine now, I know of at least a couple of dozen of enterprises who are serving not more than 10,000 customers a month, pay a bill of like 25 lakhs plus to different public cloud services. And they're not running any fancy deep learning, machine learning workloads, which has high computational requirements. These are the usual ordinary workloads I'm talking about. But imagine now, like, you need to train a deep learning model, and you have lots of data, and you pull that data thousands of times, and you spin out tens of clusters to do the distributed training. Definitely the bill wouldn't look nice. And okay, Joe is about to give up. Joe is all frustrated. Joe is all worked up, and he just wants to say goodbye. But we have a superhero. We have CubeMan now. So CubeMan comes to the rescue of Joe, So what does CubeMan do? So CubeMan consults Joe, and here's what CubeMan offers a solution now. So we all know that Kubernetes solves some of these problems already, right? There's no need to build something from scratch to solve these problems. So if you look at composability, that if you build each part of your machine learning or deep learning pipeline as a Docker container, it's very easy to handpick the containers you want and compose it the way you need to be. It's like picking the right ingredients, cook your dish, and serve. It's really easy. Composability is already solved by Kubernetes. Then we have portability. Portability is not a problem when you have Kubernetes, right? So if you can run your application on Kubernetes, your application runs wherever Kubernetes runs. So it can be on your laptop, it can be on Google Cloud, Azure with Asterisk, and AWS, everywhere, wherever Kubernetes runs. Right? This is what I was talking about, the composability, right? So you can pick the right Lego pieces, compose them the way you want it to, and build your application. Okay. So what Kubernetes also does is that since you deal with a pool of resources, computational resources, and have a unified way of interacting with them, where you have the view of a single pooled computational resource, it's very easy to ensure that your computational resources are utilized to their best, which helps you to keep the cost low. So again, Kubernetes, out of the shell, helps you to ensure that your computational resources are best utilized and the costs are kept minimal. Hey, but this is not a talk about why to use Kubernetes, right? We all know why to use Kubernetes, but the fact is that running machine learning or deep learning workloads on Kubernetes, though Kubernetes offers a lot of the facilities, straight away, it still needs a lot of DevOps expertise to be able to learn, to be able to run large-scale machine learning, deep learning workloads on Kubernetes. So Joe is again frustrated. He was all excited. Cumin was here, gave solutions, but all of a sudden, hey, you know what? Like Kubernetes is cool, but I still need, a lot of DevOps expertise to be able to package my deep learning application, train my model at scale, do the distributed training, do the coordination among my nodes, configure the nodes, service discovery. Well, Joe cries. Joe is just not happy with what Qman's offering now. So Joe, rightly so, tells that one needs to know how to package containers, and one needs to know how to write the YAML files, which is really scary YAML configurations to do your service and deployments. And you need to also know how do you serve and scale your models. And there are a few more concerns, right, which are absolutely genuine, which are like, how would you allocate the computational resources you need, right? You need, like, let's say, 10 GPUs, like 18 CPUs, and so on. And how would you easily allocate the computational resources you need to be able to easily kickstart your training and serving process? Finally, we are here. So this is what the talk's all about. So the talk's about Kubeflow, right? Kubeflow is an open source project which makes it really easy for everyone to first develop, deploy, manage portable distributed machine learning workloads on Kubernetes. So Kubeflow utilizes what Kubernetes offers and then makes it easy to deploy distributed machine learning workloads with just few commands. So basically, you have a Kubernetes deployment on your machine, might be on different infrastructure providers. And if you run Kubeflow with just few commands, you can consistently, in a portable way, run your deep learning or machine learning workloads. Right? Here's a few more facts about Kubeflow. So now, Kubeflow helps you to define your machine learning or deep learning pipeline on top of Kubernetes. So here's the first and foremost thing. No Kubernetes, no Kubeflow. So Kubeflow runs on top of Kubernetes and makes it easy for you to deploy your machine learning pipeline on top of Kubernetes. So it's not a first-class citizen of its own. But how does Kubeflow manage to do this? So Kubeflow extends Kubernetes API. Possibly what I believe is the greatest feature of Kubernetes, it's its ability to extend to build new objects inside Kubernetes, so new definitions inside Kubernetes, right? So what Kubeflow does is that it uses the custom resource definitions to extend the Kubernetes API so that Kubeflow can, in a very native manner, build deep learning or machine learning applications. OK, this is great. Kubeflow make it really easy for you to deploy, distribute, serve the trained model. But we're only talking about computations, right? There are two challenges for deep learning or machine learning processing. One is the computational challenge. The next one is the data challenge, right? And you have so much of data and lots of data, lots and lots of data, lots and lots and lots of data. Now, how do you manage to store the data in a way that not just your computation is portable, but also your data is portable, right? Your whole system is as portable as both your computation and data is. So now, again, what I earlier mentioned about was the performance challenges of using public cloud storage systems now, right? Very recently, I've worked with a company wherein they had over 1 terabyte of data, on top of which they were running deep learning applications. And all the data was on public cloud storage systems. The fact that now, just imagine during training process, definitely you wouldn't use a terabyte of data for your training, but at least few hundred GB at times, right? Now, it's very difficult, and definitely it's not simple to get a deep learning or a machine learning model right in first few attempts. So you need lots and lots of iterations, and you need to pull the data every time, and the meter is running, right? Every time you pull the data for training, the meter is running, because these services charge you for bandwidth, and ultimately that you're not just bottlenecked by performance, but also by cost. Right? Again, Kubeman to the rescue. So Kubeman also introduces Minio into the stack. What is Minio? I already mentioned Minio is an open source alternative to Amazon S3. It's available as binary for all major platforms. It's built in Go, so you get a binary for all major platforms, wherever Go gives you the build. Download Minio, /chmod, and run. Port number 9000, what you get is an Amazon S3 compatible object storage running right out of your machine. And Minio also runs on a high available mode, where it can also run in a distributed manner across multiple nodes, and which also gives you fault-tolerant capabilities. Minio is simple, it's fast, it's scalable, and the best part is it's S3 compatible, which means that if you already have applications which work and interact with Amazon S3, the APIs are consistent. So all you need to do is that redirect the same library. You might be still using Amazon SDKs. Just redirect it to point to the Minio deployment, just the IP of it, or the host name, and it should just work without any glitch. Right. With Minio, data becomes portable, and either to your bare metal cluster or to any public storage systems. So Minio also doesn't lock you in, right? It comes with client libraries, command line tools, which makes it really easy to migrate data to Amazon S3 or Google Cloud Storage or even Azure Blob Storage, right? Just with the command. And you can move whenever you want to if you feel that the fit is not right. And it's faster to pull the data over local network rather than on internet, right? Which you would otherwise do with these public cloud storage systems. And the throughputs are amazingly high. We've run crazy workloads in the past, and the throughputs are nothing comparable to what you would otherwise get with a public cloud storage systems. And yes, you do not have the bandwidth charges. Run the training for 1,000 times, a million times. Just keep running, processing the data, pulling the data, and nobody will charge you for it. And so one of the bottlenecks which are popularly witnessed in deep learning or machine learning workloads when we work on big data is the throttling or the rate limiting which the cloud storage providers, the public cloud storage providers would do, and you do not have that. So you will be only bottlenecked by what your Ethernet bandwidth can offer you, what your drives can offer you, right? You're only limited by your hardware setup. Right? How does Kubeflow manage to achieve all of this? As we already discussed earlier, Kubeflow extends the Kubernetes API. So Kubeflow is not doing anything fancy. Kubernetes already offers API, to be able to extend and build other applications on top of it. So you can think of Kubeflow as an application on top of Kubernetes. So all of us can actually extend the Kubernetes API to build anything fancy on top of it. But what Kubeflow does is that it uses the APIs offered by Kubernetes. It extends those API, which me, you, all of us can use. And once it extends the APIs, it would become really easy to write YAML scripts to run Kubeflow jobs, right? I mean, YAML configurations. YAML configurations and Joe both don't go well together. Sorry. So YAML is scary. It's probably the ops guys, the DevOps guys look at YAML and find it really beautiful and gorgeous. But believe me, usually developers and data scientists or machine learning engineers wouldn't appreciate it. So Joe is again frustrated that it's all great, my computational issues are solved, my storage issues are solved, but it's not easy for me to submit deep learning or machine learning jobs, right? Because I need to, at the end of the day, still write YAML scripts. This cumbersome YAML scripts to be able to submit deep learning jobs or to serve the trained model. Well, Kubeman doesn't easily give up on you, right? He's the Shaktiman of Kubernetes world. So Kubeflow makes use of KSONet. So think of KSONet as something like your Helm charts. So KSONet is Helm charts plus much, much more, right? So KSONet makes it really easy. Just with the tip of few commands, you'll be able to submit deep learning jobs. And it has parameters which you can set to say that how many GPUs you want. And all you need to do is that package your TensorFlow code into a container and submit the address of the container to the KSONet, and KSONet knows to take this container, take all your parameters, and run the distributed training. Right, so this is a little bit more info about KSONet. KSONet is, again, as I said, you can something comparable to Helm in few of its capabilities. So it gives you an empty template. Like, for example, it asks you what's the image you need to use to do your deep learning processing or machine learning processing. Like, how many GPUs do you need? And this template or empty form is called prototype. And once this form is filled, once you create an instance out of this class, it's called as a component. And at the end, KSONet compiles this component into a Kubernetes YAML configuration, which you need to write it on your own, right? Which is not something which Joe likes to do. And beware, if Joe gets pissed, it's not a good scene to be. And now, yes, Kubeflow has 3 major components to it. So we all know that the core component is the one which provides all the subsidiary facilities which one needs to coordinate and manage things. So TF job is the one which will closely deal with, and a TF serving too. So TF job takes in your image, number of GPUs, and all this argument, and just supply this argument. Package your TensorFlow code or a machine learning code into a container. There are already readily available Docker files for most of the popular libraries. So just fit that in. Upload the container to Docker Hub or one of the public repositories or private repositories. Give the link to it. Tell the computational resource you want, and rest of the things will be taken care. The only, I believe, the only time one needs to resort to the DevOps engineer in the team would be to get your Kubernetes setup up and running. So once you have a Kubernetes setup up and running, once you install Kubeflow on Kubernetes, which will see how easy it is to use KSONet to install Kubeflow, later all you need to do is that use the parameters, run a couple of commands, and your distributed training will be up. Right. So I'm just showcasing how easy it is to install Kubeflow on top of your existing Kubernetes deployment, right? And case is KSONet. So KSONet has a centralized registry. Just say add Kubeflow and give a link of the repository. All you need to do is install the package Kubeflow core. We already saw that there are 3 parts to Kubeflow, 3 important parts to Kubeflow. So install the code, serving, and job. So tf.serving is nothing. TF serving is nothing but that piece of Kubeflow which manages to have an API exposed on top of your trained model, so that you can consume it and build applications. I mean, again, how good is a model if you cannot build an application which your customers can use? Right. So Kubeflow is installed now, right? The first step was to get your Kubernetes cluster up and running, install KSONet, and install Kubeflow using KSONet, just few commands. Then you need to submit your TensorFlow job, right? So here are the parameters, those are available, which you can give to Kubeflow to run your job. So you have the image, right, which we already discussed. You have an image GPU. If your code is making wants to take advantage of the GPU on your infrastructure, you can give image GPU, and then the name of the training, then number of GPUs, number of workers and masters. This is for distributed training. So if you're using TensorFlow or PyTorch in distributed mode, you need to mention the number of workers you need and the masters too. So no YAML, no code. All you need to do is set these parameters, right? Just couple of commands. Just couple of commands to start your distributed deep learning or machine learning training. What are these couple of commands? Set train image and set train name. So we set the image for the training, the Docker image containing your TensorFlow code, right? And next is set train name, the name for the training, and then just apply. Oops, okay. Now, so the training might take some time, depending on the number of clusters at disposal, and also the amount of data you need to process. And all you need to do is kubectl get pods, kubectl get logs. You'll be able to see how the training is moving forward. Right. And OK, now we have a trained model. How do I build an API on top of the trained model, which later can be consumed to build applications? It's as easy as this. So now, just generate a TF serving, because since you already pulled in the Kubeflow repository, it already knows what to do. When you say KSONet generate TF serving, all you need to do is set the path where your trained model resides. You might have stored your trained model inside a Minio deployment, or it might be an Amazon S3, or it might be in Google Cloud bucket, and anywhere. It might be on your local machine. So wherever it is, all you need to do is you need to just know this. This is the variable. Where does your trained model reside? And you'll be done. Just apply. You're set. Thank you for being on a Sunday morning and giving your precious time to me to listen to me, right? Now, so just to wrap things up, we looked at the challenges of building a real-world machine learning model or to a real-world machine learning application which thousands of your customers would want to use. We looked at each one of those challenges, intimidating challenges, and then we saw how Kubeflow running on top of Kubernetes can solve these problems for you and makes your life easy to run a distributed, large-scale, fast, cost-effective deep learning pipeline. Thank you.
Yeah, so
Yeah.
what I'd like to know is, you obviously demystified, a really complex problem, right?
Right.
And you had a fantastic solution. Even not being so familiar with deep learning,
Right.
I took a lot of nuggets there.
Right.
Now, if I need assistance from you
Yeah.
to be able to deploy all this, establish this,
Right.
and seek your services, is that possible?
Yeah, that's what we do at Credaro. Thank you for giving me opportunity.
Awesome.
Yeah.
He didn't pay me.
So you can just reach out to us. Or reach out to me. What's up?
Okay. Thank you so much,
Thank you.
Karthik, for bringing KubeMan to our rescue when we intend to venture into the world of machine learning. A huge round of applause for Karthik, please.